that basically concludes the simplification of radicals on their own. We're going to include some other radical properties which will help us get a jump start on future lessons, so that we don't have to go back and do this, such as adding and subtracting radicals. Now, if you notice in example 5, I really only have radicals in a couple of the sample problems, and the reason is I want you to recognize the pattern that has taken place here. If you think back to variables and combining like terms, the variables have to be exactly the same in order to combine the like terms. So if you look at sample part A, x and x gives us x. X squared gives us x squared. Remember, you cannot add these together. X plus x squared does not give you x to the third or anything like that. It gives you x plus x squared, since they are not like terms. So, when we have a radical attached to a number, it acts in many ways like a variable does. So you can see in part C, the square root of 3 and the square root of 3 is going to give us a square root of 3. So the 2 plus the 5 equals a 7 in every single case on A, B, and C. Now if you look, however, at part D, it's kind of like having a different term. It's kind of like having x and x squared. You cannot put those two together. So what's going to require of us is this: taking the square root of 75 and breaking it up into simpler terms, and what eventually happens is we end up getting the square root of 3 on both parts that allows us to add it together. So see if you can follow along that pattern and those rules that you learned with variables, and work on sample problem 5. Okay, if we look at part A, the first trickiest part about this problem is we're taking square root of 2 times square root of 2 minus square root of 2. And you're looking at it and it looks like there's nothing to subtract. But we have to remember, it's just like having an understood 1 in front of there. So now I have a square root of 2 term and a square root of 2 term on each of them. And so I'm simply subtracting 1, which is going to give me, 2 minus 1, which is going to give me 1 times the square root of 2. And again, since the 1 is understood, I can simply say square root of 2. So it's going to be 2 minus 1. On part B, we have square root of 6, and square root of 6 is our common term. So we're simply taking negative 2 minus 3. So negative 2 minus 3 is a negative 5. And of course, we cannot lose our square root of 6. Part C, however, gives us a situation where we have one term and then we have a completely different term. So before we can combine these together, we're going to have to break the square root of 24 up so that we can get a square root of 6 out of it. So let's take a look at that process. Square root of 24 is going to break up into the square root of 4 times the square root of 6, which means we have square root of 6 times 2 times 2 times the square root of 6, which means we have square root of 3 plus square root of 6 plus 4 times the square root of 6. And now we have square root of 6 as our common term, and we can simply add the 3 and the 4 together and carry the square root of 6 for our final answer. Last but not least, we have a common term here, square root of 45 and square root of 45, so 3 minus 2 is 1, or an understood 1, so square root of 45. The problem, however, is the square root of 45 is actually not simplified, so we need to break this up and pull the perfect square out of there. And 3 times the square root of 5 is our final answer. Okay, so that's going to conclude our radicals review. And keep in mind that the premise of this radical review was mostly based around square roots and the fact that the square root is understood in the radical symbol. But however, we will be using higher degree radicals as we go on later in the semester. So simplifying radicals is going to become a very important part of your solving quadratic equations. So we'll be using this quite a bit. So be sure to learn this well. If you need to go back and re-watch any parts of this video to master this, that's going to be extremely important. Okay.